Hey, what is up everyone? Welcome to my channel. My name is Sarang, and in today's video, we are going to use the Reality Composer Pro shader graph to make a very interesting shader. We are going to make an effect of the disco ball light falling on surfaces. So without further ado, let's get into it. So we are going to start with a very fresh Xcode project. I'm using Xcode 16 beta. So you'll go to VisionOS tab, you can go to app, and then you can select next. You can call it disco ball effect. Okay. We'll use the initial scene as window, immersive space renderer as reality kit, and then immersive space is mixed. So let's just create it. All right, so we have this project. We're not going to do much work in Xcode, so we are directly going to go into packages, reality kit content, and then here you can say open in Reality Composer Pro. So that should open Reality Composer Pro. This is my window right here. We are going to start by creating a new scene. To do that, we are going to go into this bottom pane. There is this small icon that is for creating a new scene, and I'm going to click on it, and I get a new scene. I'm going to rename the scene as disco ball scene. Right. So I have my disco ball scene open here. So we are going to set up some basic primitives here so that we can visualize the shader. So I'm going to start by adding a cube, and I'm going to make a floor with the cube. So I'm going to select this cube, and I'm going to change its scale here to 10 in the x-axis, 10 in the z-axis, and I'm going to make it very thin in the y-axis. So I'm going to make it something like 0.0001. So you can see it's like a nice thin sheet that we can work with. So that's something we can start with. We'll add some more objects. For example, we can add a capsule. We can position it however we like. All right, now that we have our scene set up, we are going to create the shader, and to do that, we are going to go into the left pane, hit the plus button here at the bottom, and then we go into material and custom. So this is our material. We are going to rename it to be disco ball light material, and now you can see that we have created the material, but we have not assigned it to any of our objects. So what I'm going to do is I'm going to select all our objects, and then here you'll see that for every object we have selected, there is a material bindings property, and we are going to change that to disco ball light material. So you can see the shader basically doesn't do anything. If you want to look at the node graph of the shader, you'll select make sure that the shader is selected or the material is selected, and here you can go into shader graph. It has two nodes right now. One is preview surface and the output node. So here in diffuse color, let's try to play a little bit. If we change it, now that the material is applied to all the objects, you can see that the colors you change kind of affect everything. So for this particular shader, I'm just going to change everything to black, and we can start from there. We do want to create a repeating pattern, and we are going to use this node called noise 3D. So noise 3D generates a 3D Perlin noise. Essentially think of it as a cloud that gets generated in 3D space. So it has a bunch of inputs. One is position. Position is basically you give it a position and ask it at this particular position what is the value of noise, and it outputs that. So let's just because we are creating a light based effect, we want to connect it to the emissive color of the shader, and you can see immediately after hooking it up, you can see that here the effect is being applied. Since we want to play with position, what we can do is we can use the position node. The position node essentially gives us a position of the object, of a particular point and object to which the material is applied to. So because we are creating an effect that is going to be in the world space, we'll use the world space position of the object. So this is not the position of the object, like this is not the position you get in the transform here, but this is essentially the point, exact point at which the material is applied, so that position. So we apply that position here, and you can see that the effect is looking interesting, and we are getting a value of noise at each point separately. So you can also see that this effect is kind of very big, and we kind of want to scale it down a bit. So to do that, I'll essentially take this value and multiply it, and I'll multiply it with a scaling factor. So this would be a nice input to the shader. So I'll select the material and I'll create a uniform input in the inspector tab. I'll make sure that it's floating point. I'll call it scale. So when I create scale and I just apply it here, and then I apply it to position, you see that everything kind of disappeared, and that is primarily because the scale value is 0. So let's try changing the scale to 50. Okay. So we can see that the effect has gotten a little bit interesting now. So the documentation for things like Noise 3D is kind of sparse, so you just have to experiment. One thing I like to do is create a time node to just like pass a bunch of values and then I pass it into sine. So I'll pass it to the sine node, and because sine gives us the value between -1 and 1, what I do is I remap it. So it essentially scales the value to my liking. So here you can see the input value kind of goes between -1 and 1. Output we can change to let's say 5 and 5. When you apply it to amplitude, I'm sorry, this needs to be -5. Okay, so now you see that the value is going between -5 and 5. And you can see what's the effect of amplitude. So amplitude is kind of like the intensity of the noise at a particular point. So I'll break this connection. I think I'll go with the amplitude value of maybe 6. Okay. What does pivot do? We can essentially do the same thing. We can try applying this value, and you can see as like the pivot value, it kind of goes up. It kind of fills in the gaps in the noise. So that's what the pivot is doing. So what we can do is we can try experimenting with some values. Let's say let's shoot for -3.5. Okay, so that gives us a very interesting dotted pattern, and this is something we can work with. Okay, so I'll move this aside for a bit. So you can see that the pattern is kind of uniformly distributed across the surface, and this is not exactly what we want. We kind of want the light to go from the disco ball's position to the point on our surface. So what we need is we are going to use we need a direction vector. So to get the direction vector, we are going to essentially create another input called disco ball position. And for disco ball position, we want it, because it's a 3D point, 3D position, we'll use vector 3 for the type. All right, so what we want to do is we want a direction vector that goes from the ball's position to the surface. So we'll kind of use a subtract node, and we'll subtract these two vectors. So that kind of gives us a direction, and then we'll normalize it because we only need the direction. Right, and then the scaling that we applied here to the position, we can just apply that to normalize. So now if you see, we have some very interesting effects happening in our shader. You can see it right here. I'll change the disco ball position to maybe like 0.2 to make it more interesting, and now this is more perfect. So like I kind of raised the height of it. I think it's better illustrated if I have like a dummy disco ball here. So I'm just going to add a spear and make sure that the height of the spear is exactly the same. So here I'm changing its height to 0.2 meters. So this is ideally where the light is positioned in our space, right? So in the shader, we are using the disco ball position, which is 0.2 meters. And you can see that this is a very interesting effect that we are getting from it. So there is this issue with this effect though, that even though our disco ball is here, we can see that our light is falling on the back of our objects, where there should be like the shadow for the light. So we are going to do the dot product between the direction of the light and the normal of the object. So we'll create a normal, the normal here, you can see the inspector, we are using the object space normal. All right, so let's do a dot product. So the dot product values are going to be between -1 and 1. So when the light is kind of facing here, you can see that the values of the dot product will be positive. On the back of any kind of object on our surface, the values will be like negative. And when the two vectors are perpendicular, the value will be 0. So essentially what we want to do is anything 0 and below, we'll just ignore. So we'll use a clamp node, and we'll clamp the value between 0 and 1. And now what we want to do is we want to multiply our two values and then pass it to the output. And now you can see something interesting happening. So here you can see that the dots are not appearing here on the back, they're only appearing in the front. Okay, to make this more prominent, we can try to increase the scale of our shader. So let's try that. So we'll go to our material, let's change the scale to something crazy like 100. So you can see it's more prominent now, and it's not at the back of the object. So that's what the dot product is doing. All right, so we kind of have the disco ball light effect kind of going here. The one thing that would be interesting to do here is, like, it will be nice if this effect kind of spins around and rotates. So to do the rotation, what we are going to do is we are simply going to take the normalized direction and try to rotate it. So here, let's move the scale back so I can make some room. We are going to use the rotate node, rotate 3D, and pass the value here. Here you can see that it has a bunch of inputs as well, like amount of rotation and the axis. So you can simply see that the axis I want to rotate it is in the y-axis, so the y component is 1 here. We can simply apply the time node to the amount. Let's see what happens. And if we apply the time node to the amount, voila, we have a rotating effect. Yeah, but we also want to like control the speed of rotation. So how about we go to our disco ball material, create a new input called rotation speed. Let's make it a float as well, add. And now what we'll do is we will multiply the time with the rotation speed and then apply the rotation. So rotation speed, maybe we can set it to 3, and then you can see it's fast. If you set it to like 10, it will go even faster. So that does look nice. Okay, another thing we can add to this effect is that we can multiply our final output with some color. So again, I'll do multiply, and then let's create a color input. We can do color 3, add. Now we can pretty much set whatever color we want. So we can make the light effect red, make it a little bit yellow, maybe blue. So sky is the limit. You can also see, because of the ambient occlusion, the effect is not very apparent here. So what I'm going to do is like, I already made the diffuse color black. Let's just change the ambient occlusion to 0. Okay, so now this looks much better. So that's essentially the shader we are creating. There are a couple of things you can do. For example, the opacity of the material. What you can do is you can just take the output of the noise and you can essentially apply it to the opacity. So you cannot directly apply it to opacity. So what I'll probably do is I'll separate it in its individual components, and then I'll just pass the R value, and you can see that now the effect is essentially very you can apply this to your scene mesh, and you can apply this effect in your own space. There is one more input you can actually generate if you want, like I think intensity, if you want to add. So let's take the disco ball material. I'll create input. I'll make it a floating point input, call it intensity. Okay, and set it to amplitude. Right now it's 0. I'll set it to 6. And now you have control over different parameters. You can make it like more intense, so you can see like the effect is kind of very bright now. You can change the intensity to 6, and it's kind of like subtle. You can change the rotation speed. I think you can slow it down a little bit so it doesn't make people dizzy. You can change the color. I think the more important parts in this are essentially the direction of the disco ball to the position in the shader, and then the dot product. So that kind of makes the shader look very interesting. What's next? I'll do a very, very rough overview of like how you can apply this to your scene mesh. It's a little bit involved. I'll not go too deep. That was kind of not the point of this video, but we can also take a very quick look on how I did it when I applied it to scene mesh in a different project. All right, so when scene reconstruction update happens, you are essentially getting the mesh anchor, right? And from the mesh anchor, what you're going to do is I have this function called update model component. So you essentially want to take the scene geometry, and then from that geometry you want to essentially like apply it to the model component of the scene mesh. So here I have this function called update model component, to which I pass the mesh anchor geometry, and the geometry, what I do is essentially manually take the positions and the normal values of the geometry, and then I am generating the mesh resource from it. So I'm creating a descriptor and I'm essentially creating a mesh resource from it, and then what I am doing is I am applying I'm creating a model component, and the model component I am just passing the mesh resource and applying the material. Now you must be wondering, where did this material come from? How did I get it? So in my model, I essentially have the material here, and the way I passed it to my model was here in the immersive view. When the reality view loads, I essentially do this, where I am kind of looking for I'm just trying to find the shader graph material. So I open the disco ball scene. From that I am trying to find the shader graph material here, root, and the path is important here, so like it's under root disco light material. I think we called it like disco ball light material in our project here, but like it would be disco ball light material. And then I'm essentially passing it to the model scene mesh material. In the entity model, when it gets passed here, so it kind of overrides the initial value, and then when you kind of do when the mesh updates kind of happen, you'll see that when the meshes get added or updated, we are calling the update model function, and the update model function, what it does, it essentially creates a new model component with the mesh resource, and we are generating the mesh resource manually, and then we're passing the material as we are generating the model component. Once this is done, your scene mesh should be able to show the effect of the shader. All right, so that was mainly it. I do have one challenge for you. So you can see in the video that I have, it has this rainbowy effect where there is like the white dot in the middle, and then there are two colors on the side. This is a challenge for you. Try to recreate this effect. I'll give you some hints. To create this effect, you essentially have to make 3 copies of the shader. So if you take 3 copies, you kind of offset the rotation a little bit to left and then a little bit to the right, and then you kind of combine it, you'll get that kind of effect. I hope you enjoyed the tutorial. I really hope that you learned something interesting from it today, and I hope you'll come back for the next one. I'll see you very soon. Ciao.